Hi class, this is course 2, lesson 84, algebraic terms. Okay, so we're going to get into some algebraic thinking here, and this can be a little difficult, so please make sure that you are paying attention to all the details. Okay, so it's very detail oriented. So first we have some vocabulary. Polynomials, those are algebraic expressions that include 1, 2, 3, or more terms. And here's a chart that I want you to copy into your notes with some polynomials. Okay, this is not an example of every polynomial, just some. We can call them different names based on the number of terms. So a monomial has 1 term, binomial has 2, and trinomial has 3. And those mono, bi, tri, 1, 2, 3, like a bicycle or a tricycle. Use some of those skills that you learn in language arts to help you understand whether it's 1, 2, or 3 terms. The examples are right here. A monomial would be like negative 2x. A binomial would be a squared minus 4b squared. A trinomial, 3x squared minus x minus 4. Terms, okay, remember polynomials are algebraic expressions that have 1, 2, 3, or more terms. Terms are those things that are separated by plus or minus signs that are not within symbols of inclusion. So here there is a subtraction or a minus sign, but there's nothing else with it, so there's just one term. Here you have a term a squared, and you have another one minus 4b squared. This last example will be illustrated down here, so we'll do that one after we read this little paragraph. And this you don't have to write in your notes. However, it's very important that you understand this. When a term is written without a number, we understand that the number is 1. And when a term is written without a sign, it's understood that the sign is positive. Okay, so we're going to break this trinomial, 3-termed polynomial up. So we have 3 terms. It's 3x squared minus x minus 4. Notice that the signs go with the terms. The number value here in this first term is a plus 3, and the variable is an x squared. In the second term, we have a negative 1. It says minus, and there's no number, and we understand that that number, when not written, is a 1. This time it's negative 1, and our variable is x. The last term is negative 4. The number part is negative 4, and there is no variable part. That is a constant term. It means that value will always be negative 4. Okay, the variable makes the term value change, and since there is no variable, it's a constant term. Okay, like terms are constants, like negative 4, 1, and 15. They can be combined. We can add or subtract them. Those are just adding and subtracting numbers. You've been doing that for a long time. But we can also combine or add and subtract variable terms as long as they have the same variables with the same powers. Okay, and here's some examples. X squared, negative x, 8x squared, and 4x squared. They all have the same variable x, and it's all squared. Another example would be xy and yx. Those two terms have the same variables to the same powers. We can use the commutative property and rewrite this one as xy, and so they are like terms. So the order that the variables come in does not determine whether they are like terms or not. It's, are the variables represented, and do they have the same powers in each of the terms? So here are some examples of what not to do. These are not like terms. X squared y and x squared. Notice they both have an x squared, but this one does not have a y term. And x squared and x are not like terms. They both have an x, but one is to a power of 2 and one is a power of 1. Okay, so we can combine like terms, and to do that we add the coefficient, and the coefficient is the signed number part of the term. So first we have to say, are they like terms? So here we have negative 2xy squared plus 8xy squared. So they both are xy squared terms, so we can combine them. So we take the negative 2 and we add 8. So negative 2 plus 8 is 6, and then the variables get tacked on. Okay, we only change the number, the coefficient part. We do not get to change the value of the exponents because we are just adding. We just have more, and the more is illustrated, or fewer, by the coefficient. Here we have x minus 5x. Remember, there is no number written here, so we know it's 1, and there is no sign, so we know it's positive. So if we have 1x and we subtract 5x's away from it, we have negative 4 x's. Okay, and we can't do anything more with either one of these. These are simplified until we know what the value of the variables are. Okay, one more page, two more examples. We are going to collect like terms. Now notice in this first example, I have 3x plus y plus x minus y. So I have some x's that I'd like to get together and some y's that I'd like to get together. And I can use the commutative property and just rewrite this so that I have 3x plus x, and then put my plus y, and then put my minus y, so that I can do this part together and this part together. So that was commutative property, and then here's associative property where I'm going to group them. So again, we're going to combine the coefficients on our like terms. So I have 3x plus x. X and 3x are like terms. 3 plus 1 would be 4x. Here I have a positive y and a negative y. So plus 1 minus 1 is going to end up being, that's going to end up being 0y. And if your coefficient is 0, we don't even write it down, leaving your answer just 4x. Another way that you can identify your like terms is to circle or box or use colored pencils, and I'll do that here. So we can figure out which like terms we have. So I have an x, just an x term, and I'm going to circle the x term. So I go to this one, this is x squared, which is not x. This has an exponent of 1, this has an exponent of 2, so they're not like terms. So I'm looking for another x term, and I find one right here. Now remember, the sign goes with the term, so I circle the minus, and I know that I have a minus 1 in there. I know that that's minus 1. I also know that this is positive 3x because that sign is not written. Now I have the luxury on here of changing colors. You can use colored pencils. You could also draw triangles or rectangles or just underline. So if I were to just underline the next set, I would have plus 2x squared. So now I'm looking for x squared, and here's one right here. So I have plus x squared. The last set of like terms would be our constants. So here I'm going to draw a box around them. Remember that the sign goes with them. So now I can go over here and start combining my like terms. So a positive 3 minus a 1 is positive 2, and we don't have to write that positive 2 just yet, but I still have x's. Plus 2x squared plus another x squared is plus 3x squared, and plus 4 minus 1 is plus 3. So these are the terms that you need. However, you need to write them in descending order. And what I mean by that is wherever your variable has the highest power, that one goes first. So we'd write 3x squared, then we'd want the x to the first power term, so that's this, 2x, but remember it's a positive 2x, and then our constant, plus 3. So you count down from the variables, x squared, x, and then this would be x to the 0 power, or, it's not there at all. And that's it. That is collecting like terms, so algebraic terms and collecting like terms, or combining like terms if you like to call it that. Little different work today. Make sure that as you're doing the practice set or the problems that you ask to clarify your answers before you go too far. With that, I'll see you in class.